The motivation behind this project is that volatile organic compounds react in the atmosphere to form ozone and particulate matter, and those are two of the most important air pollutants that are in need of improvement to make air quality better in California. And these volatile organic compounds are dominated by biogenic sources in much of the state. The dominant compound is isoprene. This study set out to actually measure isoprene emissions at the landscape scale and compare those emissions to the emission models that are used for planning for the California Air Resources Board in their state implementation plan. The objectives were to verify that we could measure isoprene fluxes and VOC fluxes in general from an aircraft, to fly that aircraft measuring fluxes over the dominant regions in California that are expected to contribute isoprene emissions, to actually verify what those emission rates are, and then compare those emission measurements to the models that the Air Resources Board is using in order to both verify and then improve the models. The way we decide which areas to observe is we looked at the existing models, and we looked at one from the California Air Resources Board and one that the National Center for Atmospheric Research uses, and we looked for where those two models disagreed, and we focused our efforts on areas where the models disagreed, but we also focused on the areas where most of the oak trees in California are, because oaks are expected to be the dominant source of isoprene. So on average, the California Air Resources Board's model of isoprene emissions averaged over all the ecoregions that we flew, agreed with measurements to about 20%, which was spectacularly good. There were some small-scale discrepancies between measurement and model that mostly have to do with the land cover databases that are being used to drive the model, and we suggested ways to improve that. Follow-up research should focus on verifying the inventory using aircraft fluxes for a wider variety of species. This project focused on isoprene, but we now have the capability and have proven the technology such that we could go out and verify emission inventories for lots of other hydrocarbons, for methanol, for anthropogenic hydrocarbons, and also for greenhouse gases potentially. And that's an issue that's of extreme interest and big need for the state.